Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I am going to solve GATE 2024 problems from the subject control systems. Here I have taken the electrical paper. The topic which I have taken is common for electrical, electronics and instrumentation. So all those branch candidates can watch this video. Let me start solving the problem. So this problem is taken from electrical paper. For the block diagram shown in the figure, the transfer function. We need to find the transfer function for the given block diagram. So here I am going to find the transfer function directly. Normal method I am going to follow. Okay. So here directly I will solve the problem. So here shortly I will express this R of S as R and C of S as C and G of S as G. Okay. And here we are having two summing points. This is first, I am naming this as first summing point and this is second summing point. The output C is fed back to the first summing point and also the other part is fed back to the second summing point. So let me write the signal flow. So here C is taken from the output and it is given to the first adder. So we can mark here as C. Okay. So after adding this adder adds this adder adds R and C. Okay, negative of C and positive of R. So here R minus C will be flowing. And R minus C is given to the second summing point. And here the output, some part of output is fed back to the second summing point. So here we can mark this as C. Now positive of C and negative of R minus C is given to the second summing point. So positive of C minus R minus C. So it is simplified as 2C, C plus C, 2C minus R. Now 2C minus R is given as input to the system which is having gain G. Okay. So let me simplify this. Now 2C minus R. System which is having gain G. This is output. Okay. We need to simplify this one. So if we want to find the output C, which is equal to input into gain. What is input here? 2C. 2C minus R is input. 2C minus R is input into G is the gain. Okay. So we need to find the transfer function C by R, which is C of S by R of S. So let me simplify. C equal to 2CG minus RG. So let me take C common. So this will become 1 minus 2G equal to, in the right hand side, minus RG. So C by R, which is equal to C of S by R of S, that is equal to minus G by 1 minus 2G. That means minus G of S by 1 minus 2G of S. Okay, so let me check with the options. So option D, see the option D, we are having the transfer function minus G of S by 1 minus 2G of S. So option D is the correct one for the given block diagram. Okay, option D is the transfer function for the given block diagram. Let me move to the second problem given in electrical paper. First, I will read out the problem. Consider the cascader system as shown in the figure. Neglecting the Foster component of the transient response, which one of the following options is the first order pole only approximation such that the steady state values of the unit step responses of the original and the approximated systems are same. The topic is taken. The topic is dominant pole approximation method. Dominant pole zero approximation method. Okay. First we will find out the transfer function of the given system. So transfer, in this sense, this is a cascaded system. Gain should be multiplied. Okay. So this can be taken as G1, G2. So G1 into G2 should be G1 and G2 should be multiplied to get the final transfer function. So therefore, for the given system, the transfer function C of S by R of S equal to S plus 40 by S plus 1 into S plus 20. Okay. This is a pole zero form. So I am going to convert this as time constant form. Time constant form. Then only we can approximate the pole. Time constant form. Time constant form means 1 plus tau S formation. So I am taking 40 outside from the numerator. So this will become 1 plus S by 40. By here 1 plus S and here 20 I am taking outside. So 1 plus S by 20. Okay. So this will get cancelled 2. So this is 2 into 1 plus S by 40 by 1 plus S into 1 plus S by 20. So this is a original transfer function. Original T of S. So this is a original T of S. Okay. Now we will approximate the poles. So I am going to draw the pole. Dominant pole means the pole which is nearer to the imaginary axis. Now what are the poles? Poles is -1 and -20. So here -1 and -20 is far from the -1. So -1 is nearer to the imaginary axis. This is the imaginary axis. -1 is nearer to the imaginary axis. When comparing -40 is the 0. So that is also far. So -1 is the one is near to the imaginary axis. So we can say this as dominant pole. So other poles can be eliminated. Okay. So this is the dominant pole which is nearer to imaginary axis. That means it has the impact on the transfer function of the system. So the -20 and -40 are insignificant pole and 0. This has no impact on the transfer function of the system. So we can eliminate that pole and 0. Now, after eliminating this 1 plus S by 40 and 1 plus S by 20, eliminating this and this, the reduced form or approximated form equal to that transfer function equal to 2 into 2 by 1 plus S. After eliminating -40 and -20. Okay. This will become 2 by 1 plus S. This is the approximated form. Approximated transfer function. Okay. So what they have asked. What they have asked? Steady state values of the unit step responses of the original and the approximated systems are same. So steady state values of the unit step responses of the original and approximated systems are same. We have found out the transfer function for original and an approximated system. So we need to check whether the step response is equal for the original and approximated or same. So for that, we can use limit s tends to 0 T of S. So by substituting by substituting S as 0 in the original formation, in the original transfer function, when substituting 0, this will be eliminated and this will be eliminated. This will be eliminated. So 2. The DC gain is 2. Step response is 2. And approximated. So what about the approximated transfer function? When x tends to 0, this will be eliminated. So 2 by 1, here also 2. So we got the same answer for 2 DC gains. Okay. We got the same answer. So here also 2, here also 2. So final transfer function, approximated transfer function is 2 by 1 plus S. Okay. Now observe the options. Option B is the correct one for the given problem. After approximation, the transfer function will be 2 by 1 plus s. Okay. Let me move to the next problem. So this problem is taken from time response analysis. First, we will read out the problem. Consider the standard second order system of the form with the poles P and P conjugate having negative real parts. So here they have given the condition of pole and 0. Condition of pole. The pole locations are shown in the figure. Now consider two second order systems. System 1 is given and then system 2 specifications are given. We need to find which settling time is more. Here 4 options are given. First option A is settling time of system 1 is more than system 2. Option B is settling time of system 2 is more than system 1. Option C is settling time of both are same. And then option D is settling time cannot be computed. Okay. Now, we need to find the settling time for the system 1 and system 2. So, let me write the poles here. So, nature of the poles, they have given P and P star P star is the conjugate of P. Okay. So, negative, which is having negative real parts. So, S equal to minus zeta omega n plus or minus j omega d. So, this is the pole. These are the poles. So, minus zeta omega n plus j omega d and minus zeta omega n minus j omega d are the conjugates. Okay. So, here, these are the poles given. So, this is j omega d and this is minus j omega d. And here, this value is zeta omega n. Okay. This value is zeta omega n. So, therefore, y-axis omega d is nothing but omega n root of 1 minus zeta square. Okay. Now, finding cos theta. Cos theta equal to zeta omega n by omega n. Okay. Hypotenuse omega n. So, this is equal to zeta. So, zeta equal to cos theta. Now, theta is given, omega n is given. We need to find the settling time. Let me find the settling time for system 1 first. Okay. So, here I am going to find out settling time for system 1. System 1 settling time. So, here no tolerance level is given. So, I am taking 2% as tolerance. So, that formulation is 4 by zeta omega n, where zeta equal to cos theta. Okay. So, 4 by cos theta into omega n. So, here cos 60 into omega n is 3. Cos 60 is 0.5. Okay. 1 by 2. So, that will become 8 by 3, which is equal to 2.66 something. It is approximately equal to 2.66. We got the answer for system 1. So, let me find out for the system 2. So, for the system 2, the settling time, we use the same formulation, 4 by zeta omega n. So, here 4 by cos 70 into 1 radian per second is given for omega n. So, cos 70 calculated as 0.34 into 1. So, 4 by 0.34, this is 400 by 34, which is nearby 11.9 something. It is approximately equal to 11.8 or 11.9. Now, comparing this 11.9 and 2.6, 11.9, which is greater, settling time of system 2 is the greater one. So, find out the option. Which option is the correct one for this? Option B is the correct one. Settling time of system 2 is more than that of system 1. Okay. So, thus we solved 3 problems. The three problems taken from the electrical paper. This is Mani's Gate Tech Vision. This is the channel for engineering lectures. You can subscribe to my channel and you can view the lecture series. Thank you very much for watching the video.